Let's say I have a vector 4, 3. I'm going to name this vector R vector. So this is my origin here. So 4, 3 basically means that this vector is 4 units in x direction and 3 units in y direction. So what I'm going to do here is draw these two vectors which make R. So one vector is this vector, which is 4, 0. I'm going to name this vector A vector, and the other vector is 0, 3, which I'm going to name B vector. So from triangle of vector addition, R vector equals A vector plus B vector. This A vector is x component of R vector, and here B vector is y component of R vector. Basically these A and B vectors, they make R vector. Generally this B vector here is drawn from the starting point of R vector from here. Sometimes B vector is drawn like this. So A vector, so this is the x component of R vector and this is the y component of R vector, and these two vectors give this resultant, which is R vector. So let's say I have a vector R vector just like that, and this A vector is the component of R in x direction, and this B vector is component of R in y direction. Now I need to find, let's say the magnitude of R is R, and let's say that I know the angle which is theta. The angle of R to the horizontal is theta. Now I need to find the magnitude of A and magnitude of B. So what I'm going to do is, so there is this line here, this vector here. So here's this is 90 degrees. So from trigonometry, cos of theta equals base by hypotenuse. So the base here is magnitude of x component, which I'm going to call it A, and hypotenuse is the magnitude of our vector, which is R. So A will be R cos of theta. So basically the magnitude of x component, the magnitude of x component is R cos theta, and if you work out for the y component, you would get magnitude of y component would be R sin of theta. This is a chance for you to determine the y component. So I had x component R cos of theta, and I had y component R sin of theta. I want to find the resultant of these two vectors, so which would in this direction. So resultant, we know the formula. The formula is a squared plus b squared plus 2ab cos of theta. So a squared is magnitude of the first vector, which is R cos theta here. B squared is B is the magnitude of the second vector, which is R sin theta in this case. So 2 times A is basically R cos theta, B is basically R sin theta, and cos theta. So this theta is not this theta, right? So this theta here is the angle between the two vectors, and in my case vector R sin theta and vector R cos theta. So the angle between them is 90 degrees. So I'm going to put 90 degrees. So cos 90 is 0. So basically this whole term, becomes 0 because cos 90 is 0. So I get square root of R cos theta is R square cos square theta plus R square sin square theta. And if I take R square common, it will be cos square theta plus sin square theta, which would then give me R square, and I would get R. You can see that the resultant of R sin theta and R cos theta is R. So basically breaking down into component, R sin theta and R cos theta was correct. So I have a question here with me. So this is from Cambridge examination. The velocity vector diagram for an aircraft heading due north, so this direction is north, is shown to scale. So this figure was originally to scale, and there is a wind blowing from the northwest, and yeah, there is also a wind blowing from the northwest. So you can see that the velocity of aircraft is interrupted by wind, and it says that the speed of wind is 36 meters per second. So this this distance here, since it was drawn to scale originally, this distance here would scale up to 36 meters per second, and this distance here would scale up to 250 meters per second. So wind has a speed 36 meters per second, and the aircraft is 250 meters per second. Draw an arrow to show the direction of resultant velocity. Now on this diagram I have to draw an arrow to show the direction of resultant velocity. So we have two vectors here. One vector is the velocity of wind, the other vector is the velocity of aircraft. And to determine the direction of resultant, what we need to draw is a triangle. So because from the vector triangle we can determine the resultant velocity. So if A vector is in this direction, and if I draw B vector from the ending point of A vector, maybe in this direction, then I would get a resultant R, which would be A plus B vector from triangle of vector addition. Now I have two vectors. What I'm going to do is draw this vector to the ending point of the first vector. So I'm going to shift this vector. I'm going to shift this vector here to the ending point of first vector. So this is my velocity vector of point. Now you can see that the resultant is this vector. So this vector is a resultant of velocity of aircraft and velocity of wind from the triangle of vector addition. Now we need to determine the magnitude of resultant velocity. So basically, if you had drawn this way, you could have measured the length and then you could have written the result directly, right? But for now, what I'm going to show you is how to determine the magnitude of resultant velocity mathematically. Let's see. So I know the formula R equals square root of A squared plus B squared plus 2AB cos of theta, where theta is the angle between the two vectors. Here I have vector here, right? Two vectors are the velocity vector of aircraft and velocity vector of wind. So I need to determine the angle between them. So the angle between them is not 45 degrees. So to determine the angle between them, we have to go back to our formula derivation. The angle between them was this theta, right? If this was vector A, this was vector B, the angle between them was this angle. So both of these vectors, they must start from the same point. So I'm gonna shift. So here, velocity vector of aircraft starts from this point, and velocity vector of wind starts from this point. So I'm gonna move this wind here, so I'm gonna redraw it here. So I shifted the velocity vector of wind here. Then I now need to determine this angle. So if I draw a horizontal line, so this angle is 90 degrees because it is a vertical line, and it is a horizontal line, this angle is 90 degrees. So I had so this is the initial position of wind vector. The angle was 45 degrees. So this line and this line, they are parallel lines. So this angle and this angle has to be same. So since this angle is 90 degrees, so this angle is also 90 degrees. So this angle and this angle, they must be same. So this angle here is 45 degrees. So the total angle between the two vectors would be 90 degrees plus 45 degrees, right? So what I'm going to do is R equals A squared is the velocity of first vector, magnitude of first vector, which is 250, and B squared is the magnitude of second vector, which is 36, plus 2 times A is 250 times B is this 36 times cos of 90 plus 45, right? Because this whole angle here is 90 plus 45 degrees. Now if I use my calculator, then I'll get the answer 226 meters per second. So this is the resultant velocity. Now this is one approach to solving this problem. Now what I'm going to show you is how to solve this problem by resolving the vectors. So let's see. So this is my original problem here. Velocity of aircraft was 250 meters per second to the north, and velocity of wind was 36 meters per second, and it was an angle 45 degrees to the horizontal. Now what I'm going to do is bring this wind velocity here, right? And this angle here is 45 degrees. So what I'm going to do is resolve all the vectors to x component and y component. So you can see that the velocity of wind is completely in y direction. So this vector, it does not have any component in the x direction. It's completely y direction. Now what I'm going to do is break this velocity vector of wind into x component and y component. The magnitude of this vector is 36. So to break it into x component, it will give me 36 cos of 45. And when I break this into y component, it should give me 36 sine of 45. I have simplified this problem to this. 36 cos 45 and 36 sine of 45, and the magnitude of velocity of aircraft vector was 250. Now I have three vectors and they are all in x and y directions. Subtract this magnitude from this magnitude because both of them are in y axis. So the resultant of these two would be 250 minus 36 sine 45, and in the x direction it will be 36 cos 45. So now I have only two vectors, one vector which is magnitude 250 minus 36 sine 45, and the other vector 36 cos 45. And since these two vectors are 90 degrees, the resultant of these two vectors would be 250 minus 36 sine 45 squared plus 36 cos 45 squared. So it's basically the same formula, a squared plus b squared plus 2ab cos theta. Here the theta would be 90 degree, cos 90 is 0, so that term would be 0. So only these two remain. Now if I use my calculator to get the value, 226 meters per second. So what I did here was break down all the vectors into x and y component, and then at last be left with only two vectors in x and y direction, and that way I can find resultant easily. I hope you understood both of these methods. Now let's look at one more problem. So here a force of 5 Newton may be represented by the two perpendicular components as shown. So not with scale. What is the magnitude of OX? So this is the resultant force, and this force is broken down into x and y components. So I need to find the magnitude of OX. OX and OY are x and y components, and this is our resultant vector. So we know the formula resultant equals a squared plus b squared plus 2ab cos theta. Here theta is 90 degrees, so cos 90 will be 0. So my resultant is 5 equals a squared is 3 squared plus b squared is the what I need to find, x squared. Now if I work this out, I would get x equals 4. So C is our answer. A vector quantity v, so this is our vector v, quantity v, is resolved into two perpendicular components. So it is resolved into x and y. And the angle of b to the horizontal is theta. The angle theta is increased from 0 to 90. So angle theta is increased from 0 to 90. Write that down. How do the magnitudes of x and y change? So how would the magnitudes of x and y change as theta is increased from 0 to 90? So let's think about the case when theta is 0. So when theta is 0, this vector v would be in x direction. So our x will be completely v. And in this case, the component y would be 0 because a vector in x direction has no component in y direction. As theta is increased, the vector quantity v has component in y direction. So basically, component of y starts to increase, right? Component of y starts to increase. So if the component of y starts to increase, the x component, the magnitude of x component must decrease, right? So C is our answer. Also, you can find it this way. So x would be v cos of theta, and y would be v sine of theta. So when theta is 0, cos is maximum, right? And when theta is 90, cos gives value 0. So you can see that as theta is increased from 0 to 90, the value written by cos theta decreases from max to 0, from 1 to 0. And in sine, it is exactly opposite. When theta is 0, sine 0 is 0, and when theta is 90, sine returns the value maximum. So in y component it must increase, and in x component it must decrease.